All right, good morning, everybody. Welcome. Hopefully the conference has been another great one. Seems like the sessions have been really good. We were just talking about that. I'm Steve Langford from Beaverton, and this morning we're going to be talking about stretching the virtual infrastructure. Eric Horn is one of our system administrators and is going to be sharing with you. So please welcome Eric.
So, yeah, I'm Eric. I've been at Beaverton for, I don't know, according to HR, 20 years. And I've been using VMware since, GSX version 2, if any of you actually remember that far back. It's quite a ways back. And if you have any questions after the presentation, my email's up there. I'll have it back at the end as well. I do have a lot of slides, and I hope I can get through it all in time. There's tons of information.
Will they be posted?
I can make sure they get posted somehow, somewhere.
Hey, Eric, are you recording, by the way? Is that
Yes.
Okay, cool.
Yeah, I'm going to do kind of an overview of what we were looking for, and then kind of roll into an overview of how the product works, and then kind of get into the details of specifically what we did, towards, well, hopefully not the end, but yeah. Anyway, so when we started this, we were looking at, we had specific goals. Increased availability was a big one. Some of you have probably heard, Beaverton has had its, probably more than its fair share of major data center issues. A couple of air conditioner failures that went unnoticed, over a weekend. A fire suppression system that randomly dumped without telling anybody. Typical stuff. So, yeah, according to our users, system access is critical. It doesn't matter that they only use something once a week. It always has to be up. And we also just recently finished building a second data center. So we want to take advantage of that. We don't necessarily want to throw the old one away either. And we also have, due to previous, near disasters, a DR project that we're working on. So we want to lay the foundation for that so that we don't build something and then have to rebuild it to fit the DR plan. We needed to replace our hardware. We have hardware that was, past the end of life. Dell wouldn't touch it with wouldn't even talk to us about it. It was so old. And we were also starting to outgrow the size of the cluster we had. We have increased performance needs. Our old infrastructure was old, based around 1 gig networking, and we had at most 4 gig of bandwidth going into the infrastructure. And 4 gigabits sounds like a lot until you try and run 20 terabytes of backups through it. It gets really, really slow. Our storage was at least a little more modern. We had a couple of 10 gigabit iSCSI arrays. The concept worked really good. It's just, once you get so many VMs, your I/O workload turns more random, and we just didn't have the IOPS to keep things moving snappy. And then network security. We had a flat network, no DMZ, just perimeter firewall. You were either inside or outside. And when 20 years ago, a lot of our services were exposed to the internet, especially the most critical ones. So DMZ really didn't make sense. But nowadays, our internal users are getting more talented. So we really want to keep our 50,000 potential hackers away from the stuff that they shouldn't be able to access. So for our initial decisions, we want clean slate. We didn't want to constrain ourselves based on, this is the way we've been doing things. This is, in the time I've been at Beaverton, this is really our first major overhaul that I've done, or that we've done in the network infrastructure. I mean, yeah, we moved from 10 megabit to 100 megabit to gigabit, but realistically, the underlying network structure hasn't changed in that time. So, yeah, we didn't want to keep going down that road if it wasn't appropriate. We also wanted a highly available stretch cluster so that we can pick things up and move them back and forth between the data center. And, in our case, we wanted it to all happen transparently. So if, something, smokes out in the middle of the night, I don't have to get a call. Yes, I'm lazy. I like to sleep at night. The other thing that drives me nuts personally is, active passive systems. I really don't want half of our hardware sitting there doing nothing. I mean, it just doesn't make sense. If it's there, make use of it. And the other thing that was kind of a concern at the time, we wanted products that we could actually buy at the time. When we were looking at this, we talked to several storage vendors, and they all had the features we needed next quarter. And yeah, I've been burned by that before. So, it's, actually even Microsoft, we were looking, it did take some time to look at Microsoft. Unfortunately, they were, for us, they were in the same situation. Azure Pack had been out for about 2 years at that point, but it was still beta with no release in sight. Unfortunately, it released it about 3 months after we made our decisions, but by then it was too late, and that very well could have changed how we went forward. So yeah, I'm gonna break it down into storage, then the network infrastructure, and network security, because storage kind of lays the foundation for everything. Network infrastructure is communications, and network security was, to be honest, we really didn't know what we wanted at the time. We just kind of grew into that. And then last, I'll go into a little more specifics exactly how we did it. Okay, so the storage. Storage requirements. A highly available stretched cluster needs cross-site synchronization of your storage. Real time, not time delayed, because I'm also a DBA, so it's like once something gets committed, if something fails, it better well be there upon recovery. And my definition of highly available is that anything less is disaster recovery. So yeah. At the time, we were also looking at having not a lot of bandwidth between the two data centers, and not a lot being 10 gig. When you're replicating storage and network traffic and all of that, that could easily be a problem. I mean, by comparison, our old iSCSI based storage systems, we had, I think, about 40 gigabits of bandwidth in it. So, this was, we were really looking at this as making, wanting to make sure we're not downgrading. And we also wanted to be able to scale the system. So, storage is based on vSAN, which it's basically server storage that gets distributed. It's kind of equivalent to like Storage Spaces Direct with Microsoft. In fact, it's very, very similar. I looked at both at the time. There was a couple of minor concerns on the Microsoft side, but nothing I don't think that would have stopped us from using it. Basically, storage gets organized into disk groups. Disk groups basically, up to, 8 disks, 7 disks, 8 disks. On a server, each server can have up to 5 storage or disk groups. And you have capacity drives, which stores all your data. These are cheaper drives. If it's SSD, lower endurance, higher capacity. And then you have the cache drives. And the cache drives cache. If you have SSD cache capacity drives, the cache drives are caching writes only, which increases your longevity, because less writes are passing through to the underlying storage. It also helps a lot if you're using deduplication and compression, because it doesn't deduplicate the data immediately upon write. It waits till it evicts it from the cache. So you have the performance benefits there. So you can have huge bursts of write activity without having to slow down for it. Unfortunately, those cache drives get beat up pretty heavily. So they, in order to get certified, they're higher endurance drives. They tend to be a little more expensive. Actually, all of these drives are more expensive because they're enterprise grade.
NVMe?
Huh?
NVMe?
We didn't go that route. It was pretty expensive. Actually, our system's SATA based. So, when we were rolling this out, it was in the middle of the SSD crunch about 2-3 years ago. We by the time we get one set of quotes, we go to order and they tell us, yeah, we can't get those drives anymore. They just stopped making them because they moved on to the next model, and we had some issues sourcing them. That was when we bought the first half of the cluster, because we wanted to do some testing before we fully committed. So we only bought 4 machines. When we went to buy the second half of the cluster, different SSDs, because they had changed. The price had gotten a little better, and actually since then we recently got some more capacity, and I think the drives are like 25% of the cost as they were when we originally started. I mean, the prices have just crashed on those things. So vSAN storage is based on policies. You really cannot say put this here. You can tell it, make sure it'll tolerate a certain number of failures. That would be typically, tolerate 1 failure, which will cause vSAN to make 2 copies. You can do higher than that if you have critical data. If you are running an all-flash system, you can do RAID levels other than RAID 1. They have RAID 5 and 6 available. If your cluster is big enough, I think you need a minimum of 4 machines in the cluster to do that. You can also do things like set the minimum number of stripes. We've not really had to do that, except for one really big VM we have, which we put our SQL backups into. And the only reason we did it there was to help distribute things across the entire cluster, because it was performance-wise, we were overrunning the cache drives on the disk groups they were in, so we just wanted to distribute it a little bit more.
When you're making these configuration settings, are you actually configuring at the level of the number of stripes?
Basically, you assign that to the policy.
Okay.
And then you assign the policy to a specific VM.
And you're controlling the policy. So we went the S2D route, and it's a little bit more wizardy based. And you can, PowerShell and get real granular with it. But a lot of it is all right, do you want a 1-to-1? You want a 1-to-2? A 1-to-3? And it's this is what this means and how much available storage you'll have. And then it kind of takes care of it from there.
Yeah. Number of stripes doesn't affect the performance, or doesn't affect the amount of used disk space. It's just, how much does it spread out across the cluster. Because, your typical VM is going to be 1 stripe. There's just going to be 1 block here and another copy on a different machine. Let's see. vSAN breaks everything down into components. And I only mention it because that's where all the redundancy is. It does not mirror disks. It mirrors or replicates the virtual objects themselves, which is actually good, because if you have 50% free disk space and you're remirroring due to a disk failure, why remirror all the unused space? And they do break it down. Every object gets at least 3 components: 2 data and a metadata. The metadata basically is saying which of the 2 are good. Basically, if you've done clusters, it's a voting system. The best 2 out of 3 win, or in this case, actually, it's greater than 50%. Stretching vSAN is actually incredibly easy. You literally just go check a box, tell it where the witness is, and make sure that you have all the networking pieces in place. It does change a few things. Basically, vSAN, when they did the stretched cluster support, they made it intelligent. So if you are doing disk reads from site A, it's not going to route them to a disk at site B unless there is no copy at site A. So that helps with our network efficiency. As far as the system requirements, they have pretty strict requirements for bandwidth and latency between the data sites. The witness site, it's a little more relaxed. They allow a little higher latency. Basically, they built this for the real world. So, they expect that your witness could be somewhere out on the internet.
Where did you put your witness?
Our witness, we just built a new high school, Mountainside High School. It was designed as a disaster shelter. So it's heavy duty earthquake, the generators, they got everything there. So we decided to go ahead and put it there.
From a witness standpoint, this scenario, can you walk through the different scenarios that you could potentially experience and how your witness and how that would function?
You mean like how the failures work out?
So let's say your site that has the witness, that's the site that fails.
Mm-hmm.
Your other site...
We'll just go on to the next slide.
Just a quick question on that last. So what your inter-site links, are you at like 40 now, or what are you at right now for bandwidth?
At this point, we just moved to 40.
Okay.
Yeah, I have and it's actually quite a bit different. I have a couple of slides a little further on that actually gives a better map of what it looks like.
Are there shared circuits with other data in transit, or is it dedicated for storage?
They are shared.
Are you doing any QoS, or how do you protect that strict requirement?
At this point, it's between the data sites, it's point to point. So the only data that would be crossing is data that's really going to that site. And at this point, we don't have that much crossing between the sites. Okay, so failure handling. An object is available as long as 2 of the 3 sites are online. That's simplified. It's actually, as long as all of, if it's split into multiple components, as long as all the data is available and more than 50% of, the votes are in, and it's, just the same thing that any other cluster would do. It's, the risk is if something's available but you have less than 50%, it might actually be the one that's out of date. So
when you say 3 sites, are you referring to 3 physical?
2 data sites and a witness.
And your witness is, say, at one of the data sites?
Our witness is in a high school, and then we have the 2 data centers.
Oh.
Yeah. If you have a witness in a data center and that data center goes down, there will be no failover to the other one because you only have 1/3 of your votes.
Now, what if both sides, so let's say the network, like the connectivity between the network, so you got your two data centers, and that link between those two gets severed.
Yep.
But your witness is, say, in the cloud.
And it's working for both, yes.
And it's working for both. How does that...
That really falls into the category of split brain. And with vSAN, with a stretch cluster, one of the sites is designated as preferred. If the two data sites cannot talk to each other, but both are talking to the witness, the preferred site will take over, the non-preferred site will shut down. And then, which will trigger the failovers of the VMs through DRS.
That's it. So preferred site.
Yeah. And that concept of preferred will come back as well.
So don't put your witness at one of the data centers.
No, not unless you only care if the one data center is up. Now, for purposes of a disaster, we did set up our network so that we have ports available at both data centers that we can literally go, if something happens to, like, something major where we have links down, earthquake, ice storm, something, we can go to the witness site, pull the witness, and take it back to the data center and bring it online.
This in the realm of the Hyper-V area, you can also just provision a new witness.
Yes.
And say, hey, yep, this is the site that wins, and then you go to bring the other ones back in. There's just a little bit of a process.
Yeah. The other thing you can do with vSAN is you can turn off stretch cluster. However, my big concern about that would be you're basically designating a site as valid when, depending on the order of the failures, may not necessarily have all the most current data. So if a host fails, no big deal. The disk groups in it will go down and start rebuilding based on the second copy. We've not had any host failures other than intentional. We put it into maintenance mode and spend a few hours doing updates. Same thing, disk failure. If you lose a cache disk, the whole disk group goes offline. It'll rebuild somewhere else. Data disk failures depends on if you're using deduplication and compression. If you are, the whole disk group goes offline. If not, single disk will drop offline and it will rebuild.
On the rebuilding side, so one of the things we ran into this where we missed this in the documentation when we were doing our implementation, but there was a minimum requirement of unallocated disk space. And this may be unique to S2D and Failover clustering, but there's a minimum requirement on a disk space to do rebuilding that you cannot. So when you create, here's the pool, here's the volume to create on the pool. Like, well, let's just fill up, the pool with the volumes we need. And we had a failure, and we did not leave enough unallocated space in the pool to be able to rebuild when we had an incident occur, the disk and the logs, sad day of logs. Okay, incident occur, data loss, rejoining into the cluster, rebuilding the disk, error, not enough disk space in the pool to rebuild disk, ejecting disk, go. No, please no.
You do have to keep a free amount of free space, and that amount of free space should be, assuming you have the same amount of disk space across all your hosts, double with a stretch cluster, double of one host, because you have to make sure. And we did the same thing, made that one mistake, and I shot myself in the foot really good, because when we first started, I started thinking of the storage in terms of, let's just keep 4 copies of everything. If something fails, it doesn't have to rebuild across the network. The second copy's already there. Well, I kind of got too much into that mode of thinking and forgot that, if one of those copies goes away, it's still going to rebuild it. And
it told us And I looked at it, it's like, huh, that alert must be a bug.
I know, man, like turn around, it's like they're low on space.
There's 50 terabytes of free space there.
Yeah.
But it was all at one site. And yeah, that was a bad day.
Can you write your rules for logging to the alerts when you fall through that threshold?
Most likely, yes.
Okay.
Although, at least with the alerting system, they would be fixed. So if you add more disk beds, you have to go back and fix the rules.
Yeah, and you're manually setting the volume, so it's not doing it itself. Yeah, you have intentionally decided to do this.
Well, the nice thing about vSAN is it's a big pool of space, so you don't really have to reserve it. You just have to make sure you don't use it. So it's not like a separate area.
So from another failover standpoint, so the way that you plumbed up the network component here, are you running, how many NICs are you running out of each box?
3.
So 3 NICs, and do they have specific purposes?
They're all bound together in ACP.
Oh, okay, so, okay.
And there's actually one other important thing to note with vSAN. Temporary failures, like when you take the system down and patch it, if a failure is determined to be temporary, it will wait an hour before it starts rebuilding, unless you tell it otherwise, which is really nice because you cycle through all your cluster to patch it. You don't want to rebuild it.
So one of the things, so with the rebuilding, so the way that, so in ours, when we go to do patch management, there's a utility that kind of automates, or you can manually do it. And there are 2 things that each host is doing. There's 3 probably. But so it's hosting a VM, but it's also hosting the control, the metadata for a disk that lives within the cluster. And when we go to apply the patch, one of the actions it takes is it will shift the VMs to another host, and it'll shift the disk metadata to another host, and then it applies it, does the reboot. So seamlessly all of them.
Yeah. VMware has Update Manager. You can literally just hit go, and it will cycle through your cluster. I don't trust it enough. Our cluster's too critical. I tend to do them one at a time. In terms of patching, a lot of times I will patch one of the nodes, like towards the end of the week, week only Friday. Let it cook over the weekend, and then if panic, then continue on with the rest of the cluster. So I always let the patches go. I mean, we did have a problem one time where we did have a patch with a faulty NIC driver, which took a node out. Users didn't see it because at that time we had 2 different brands of NICs and servers just in case. We never thought it would happen, but it did. And the system happily migrated everything off using the remaining NIC, and nobody ever knew that the system went panic.
Well, I got a bad version of that story. So we had the same thing. So we set the policies to manually update, so it wouldn't do it. But it turned out, so we set it on the boxes initially, but in 2016, after the fall update, it stopped looking at that and started looking at the set root policy for it, which we hadn't configured properly or hadn't configured at all. So it did download the update and it applied the patch to it with the forward driver on the NIC, and so the NIC stopped functioning properly. And on our machines, we had 3 NICs, or well, yeah, we had 3 NICs, and what we did is we separated the data network versus the access network, or the storage network versus the access network. And it only affected the access NICs. So they went offline, but the data network stayed up. So 40 gig links across 2 sites, everything went fine. And the cluster was like, I'm fine. So we get a call Monday morning, hey, we can't access blah, blah, blah. We pop into the cluster, we're like, well, the cluster says it's healthy, I can log in. Like, so then we try the service, and the service doesn't respond, and we do the thing. But that was, sounds like you don't have that because you got them all placed through there.
Well, it's not running Windows. So there is no automatic updates. You initiate with VM, or you initiate. Now, for the failure scenarios, we did test all of these. before going live, just to make sure that it did function as described. So, yeah, VSAM, pretty simple. Okay, network infrastructure. This is where things start to get a little icky. Our requirements there, we wanted no stretched physical network segments between the sites. We wanted everything to be routed. Turns out this actually saved us because our infrastructure has actually evolved quite a bit even since we started this. Basically, our networking team did not want to have to deal with whatever the current version of spanning tree is and making sure that that is working as we desired. So we wanted it all routed. We also wanted network to be efficient just because we had limited bandwidth to get raw wasted. We want to be able to pick up and move a VM from site to site, no interruptions, no reconfiguration, it just boom, done, works. And highly available, obviously. No single points of failure, and it must be able to route around problems because with physical networks, problems happen. The other thing we did, we moved all of our servers from our public IP range into the private IP range. So we needed to be able to deal with address translation for the items that receive connections from the internet. We also have load balancing requirements for servers. We have been using physical F5 load balancers. However, high availability of those in the virtual infrastructure just wasn't feasible going forward.
This is super quick. What was your primary reason for going to private range with the scalability? Just briefly, sorry.
We wanted to get the structure adjusted so it wasn't tied to a physical resource.
Okay.
The one thing that is a challenge with this, if you have, right now our public IP range is a physical network, we would not be able to pick that up and virtualize it, be able to move it back and forth between the data centers without stretching that daily, because the router is physical in one location. Basically made things easier. The other thing is once we dig into DR, most likely will not be able to take those public IPs and move them to the DR side and have them actually move. Okay, so NSX is the networking component of VMware, or at least the advanced virtual networking. It has the virtual equivalents of everything you need to build a network. You have your routers, which they call edge service gateways. That's kind of like their Swiss Army virtual machine. Kind of does everything. You have the distributed routers, which are highly optimized, built into the hosts. It's designed to get things from virtual machine A to virtual machine B with minimal latency and not crossing the network when necessary. The edge routers, the edge service gateways, there's more for getting things from your virtual out to the rest of the network. You have switches. They call them logical networks. You have as many as you want. If I get a chance, I'll show you what we have. We have not hundreds, but probably not too far from that. The edge service gateways do load balancing, and firewalls are covered. I'll cover them a little later, but spread out a little bit. So, first step in setting up NSX is you deploy the management layer, which starts with the NSX manager. It's just a VM that keeps track of your records. Integrates with vsan. If you have to do disaster recovery, yeah, that's one of those things you want to keep, because during disaster recovery, a lot of the virtual networking stuff, the edge service gateways, you just hit redeploy and boom, magic happens. They're back. Network controllers, they basically deal with keeping things operational. there's 3 of them. And it's cluster format, so you have to have at least 2 of those 3 online for full functionality. It keeps track of the locations of the VMs and the IPs of those VMs. In order to cut down broadcast traffic, ARP is basically virtualized, so ARP requests generally will not cross the network. The network controllers know where all the IPs are, and it will send a virtual response back. Basically, one of their goals was to just cut down on the broadcast traffic in general. The other thing the network controllers cover is the routing tables for the distributed routers. Since those routers are distributed routers in our case spread across the 8 coasts, something needs to keep them all on the same page. Our first big problem when we did this is those network controllers are not stretch cluster friendly. They have a single static IP, and they have to be attached to a physical network, which when you consider the no stretched VLANs, that's a problem. Because in order for this to work correctly, they have to be able to move between seconds. We cheated. Our top of rack routers have VXLAN functionality. So we went ahead and set that up so they're tunneling what turned into our management network. So all of our hosts are connected to that physical network. It's encapsulated in VXLAN and shot over to the other site if necessary. Brocade. Yeah, BDX6.
When you ran into that, Eric, how long did it take you to figure that out? Implement that, to start something that bad?
Not that long. Based on the documentation, we suspected there was going to be an issue with it. Salespeople said, you're fine. It'll work. Yeah, we did some testing and quickly started putting the pieces together and realized, the distributed routers rely on them. If they go down, like because they're all on one site, because actually they recommend you put all of them in one site for not necessarily VMware, but other VMware users, because if only 2 of them are online, that's fine. If only 1 is online, it goes into read-only mode. At that point, it's basically worthless, because if you have a site failure, the first thing that's going to happen is all that routing is shifting. And since it keeps the routing records, it's a loss. So we have them set up so they can load back and forth. Yes, there will be a temporary disruption because they have to get started up at the new site before routing tables will start synchronizing again. But then again, since all of the VMs were on the site that died, are restarting as well, probably not updated. Another part of the management layer, there's host software that gets installed, so it's an integrated solution. And that the host software covers distributed firewalls, which I'll discuss a little later. Physical layer. NSX is built to run on a network. They don't really care much about what it is. The virtual machines never see it if you do it right. It's just there to get data from point A to point B. But since all that traffic is encapsulated in VXLAN, a standard 1500 byte MPU for your VMs, which unless you want to have to do special configuration with each one, probably do. Your underlying network needs to have larger than standard frames. When we built ours, we went ahead and set the frame size up to the highest we could, which was 9,000, which means we can't do any VMs with the MTU larger than 8900. We weren't planning on doing jumbo frames on VMs, but building an infrastructure that you're going to be stuck with for the next 10 years, you might as well take what you can and hope that it's there. Network security requirements. Basically, we want to put a firewall in front of every VM since we have our flat network. Pretty much, I kind of like to view it as our internal network is basically a DMZ. We don't trust anything in it. Yes, OS firewalls, insufficient because each system is standalone. We want it in the integrated package where we can make rules and not have to make rules on every VM. And our vendors really like to turn that off, even though we tell them not to. And even after we tell them not to, they still turn it off. Beyond that, at the time, we really didn't have a clear idea of how we were going to set that up. Because, well, security is an afterthought. It's changed since then. We did come up with an idea, and I'll show that a little bit later. So, how we did it. We have 8 cluster hosts, 4 at each site. Just a standard 2U chassis with 24 disk slots. Since it's licensing is a really significant portion of this, we got the absolute fastest CPUs we could. The most amount of RAM that we could put in it without causing a performance change. Because I know some Intel CPUs, the more RAM you put in, it slows it down. And then 4 ports of 10 gig Ethernet with VXLAN offload support. So basically a server thing. We ended up choosing the more nice DIMMs. They've been working great. We'd originally chose the Intel ones. We had problems. Later on figured out I shot myself in the foot. So.
You bought the Intel one?
No. We were having connectivity issues due to a misconfiguration. We didn't realize what was going on until we got the second set of NICs and got the same problem.
You want to briefly elaborate on this?
Well, we have 3 top-of-rack routers. Therefore, 1 link from each server to each top-of-rack router bound together with LACP. Leaving room for future expansion, we have 4 NIC ports. So I set up LACP on the server side with 4 ports, 3 ports on the switch side. Well, we've done that on Windows servers before. No problem. Yeah, VMware, I guess technically it's a spec violation. Windows doesn't care. It just works around it. But VMware, all of our broadcast traffic is heavy off into never. Going down virtual port number 4, which was non-existent.
Oh, sure.
So yeah, really weird. Took us forever to figure out what was really going on. We also have a 16 gig SATA DOM disk, which is basically a thumb drive with a SATA port flipped into the motherboard, just for the OS. We did not want to chew up a disk slot for just the OS, because we have 24 disk slots, and we decided to do our disk groups with 1 cache disk, 5 data disks. That's exactly 24.
So the cache, no redundancy in that?
No, the redundancy is in the servers.
What brand? Not disks, but servers.
Oh, servers. When we looked at it, we did a price comparison, basically we called up CPEnw and said, hey, we don't care what brand, give us quotes. And we compared it to Dell. We ended up with Supermicro because they were about 30% less. But we did cheat a little bit because when you have something as redundant as this, you don't need next business day support or parts replacements. If the disk goes out, it's offline for a couple of weeks, doesn't matter. the system's fully redundant. So we went with a lower level of support and saved us 30%. That's pretty significant. So yeah, with our cache disks, 800 gig, 60, depending on which half of the cluster due to availability issues. Something else I forgot to mention earlier, the cache disks with vSAN, if you're running an all-flash vSAN environment, that disk is only caching disk writes. Disk reads all bypassing over disks. If you're doing a hybrid with spinning disks, that cache disk is split between reads and writes. The one thing that they don't tell you is there's a maximum size of write cache on a cache disk, and it's about 600 gig. So you don't want to get really big cache drives if you're doing an all-flash environment, because it's just getting used.
So that's a limitation?
I guess so. I never really found why. It took me forever. I always seen the forums and stuff. You see references. It's like, yeah, don't do this over this amount. It took me quite a while to actually find the source of that.
Is that in the vSphere environment?
Yeah, vSAN just will not allocate more than a certain amount of disk space for a write cache. So, we went with the 800s because they recommend cache disk be about 10% of the capacity disks, depending on your workload.
Is there any correlation to not just the size in relation to your spinning, but also to ratio of physically a 1:4 or a 1:2?
They recommend it based on capacity, 10%. You can only go up to, I believe it's a 1:6 or is it 1:7.
So the Microsoft, they not only have a capacity recommendation, but an actual count recommendation. Does it work without that? Yes, it does.
Yeah, I think vSAN has a hard limit because I think it was 8 disks per disk. Basically, they don't want people creating a really big, like the problems with grade 5, get too big of a tray where they failed before it finishes rebuilding. I guess it's kind of the apples to oranges, but they want to keep things small enough so that it's more modular. Our witness machine it's just one CPU, 64 gig of RAM, whatever NIC was built into the motherboard, and 900 gig of grade 5 storage. If you do a vSAN witness, I would highly recommend that you have the option of running vSAN on the witness itself, or they have a witness virtual appliance. Pick the virtual appliance. It's a free license. Because they comp the license for that, and you don't have to put vSAN on the witness host itself. And you can also then use it freely for other things. Like our witness host also has a Windows machine on it that serves as the witness for our secret cluster. We have a total of 6 topic rack routers, and they really are routers. We have 3 per site. We're located EDX series. Our networking team chose them, so that's it. I don't know what went into choosing them. Okay, so vSAN. When we did it, we literally followed the instructions, and it worked. The one issue we did run into, which isn't a problem with vSAN per se, but Supermicro, the system was fully certified as vSAN compliant when we bought it. Shortly after we bought it, they released 6.5 update 1. It's like, cool, an update. Just since we're not quite in production yet, we go ahead and get that installed, everything will be good. What I learned after that is hardware certifications are basically update dependent. So something that was certified for 6.5, no updates, may not necessarily be certified for 6.5 update 1. or update to. For whatever reason, the vendor decided to not certify a disk controller. A big gap between 6.5 and all the way up to 6.7, which is basically the equivalent of like 2 Microsoft Service Packs.
And you're forever stuck in that.
Well, basically, yeah, once we updated, it's like, I contacted support, it's like, hey, I think there's a problem with your hardware compatibility list. Tech support guy said, yep, it'll be fixed in the next release. A year later, yeah, figured out it will be a story.
So then, will the vendor support the equipment?
Well, VSAM, call VMware. Yes, they can choose not to. They can say, yeah, it's because you want to support the hardware. We've not had any issues with that. We're getting real close to being able to upgrade to 6.7 this summer. Unfortunately, our voice over IP system is not. They're kind of draconian. They only support 6.5. And actually, which is a step up, because a year ago they were certifying specific build numbers, which, yeah, that sucks. The same vendor also doesn't certify Windows updates either. Okay, so this is what we planned for network-wise. High level overview. We have central office and cap center, which is our second data center. Single 10 gig link. We have Comcast that serves all of our connections to the schools. Those are lower speed connections. I think we have about 7 or 8 gig of usable bandwidth leaving through this purpose. The thing about Comcast is they don't support jumbo frames, so we can't use it for our VX line traffic. But our schools are up there, and that's where our witness is. So slower links going to the witness, a single high-speed link between the data centers, and then we have ESD off to the side, which provides our internet. Now that's what we had planned for, so that's why we were really concerned about our network bandwidth, because single 10 gig link, I can see that being pretty easy to swap.
Question on that diagram. So let's say Comcast is something that like there's a so both of those centers come back Comcast.
But that will only affect witness traffic for this purpose. It will affect connectivity to the school, just in general.
So if I think it's a scenario. Let's say some disaster happened and like all that Comcast traffic goes through the one CO office and down, it gets taken out, and one of your other centers gets taken out. I mean, there are bigger problems in the area probably, but at that point, if the witness is unavailable and one of the other centers is unavailable, then does that remaining cluster still function?
No, because, and this goes back to the voting system, that part of the cluster doesn't know. It could be that the other 2/3 of the cluster is working it. It can't talk to it. So since it doesn't know, for data consistency purposes, it really needs to shut down.
Now, if you had a witness in the cloud, and both of those still had connection to the ACPEnw internet, and one went offline, the other one would function.
Well, I don't know which data center it is. At the time, I think we only had connection with one of those buildings. But it's actually kind of changed a little bit. This is still a really rough overview. We now have 4 10 gig links between the 2 data centers. That's still 1 pair of fiber. Fiber, I'm not sure. But basically, okay. It's his fault. He told us about some really cost-effective multiplexers, not multiplexer,
Who's done Lambdas? Like, yeah, it's the
Dense wave division multiplexer.
Yeah, what you're talking about.
I guess, multiplexer. So basically, we have 4 10 gig links. Our networking team decided to go ahead and not do LACP on those. Those are individually routed because LACP is not load balanced. Exactly. Right. A single session can still only get 1 link's worth of bandwidth. So they went ahead and routed it and turned on ECM so that the router can distribute however it sees fit. The other thing that happened is, and it's not exactly drawn here, but our ESP set us up with basically a VLAN that routes through them back to our data center. So we have a second backup link. Because we had to have the links there anyway for internet access. So, you're using multiplexers as well, so it was really not a big deal for them to do that for us. So we now have 4 primary links and 4 primary 10 gig links and a backup 10. We still have Comcast as a limiting factor to cover the site. However, that's going dark fiber in a year or 2, so that will be covered. So that'll be dual attach with the ring. So the physical connections, we've already kind of touched on it. We have each host server has 3 10 gig connections going to 1 connection each top of rack router. And those top of rack routers do LACP across physical boxes, which it's nice. And if one of them drops, the link will go down. Everything keeps on going. We did have to set up 4 VLANs. The one management one, which is bridged via VSAM by another router. vMotion, which is typical VMware recommendation. We have a routing network, which basically will interface the routers to the virtual routers. And then the VXLAN network. At this point, I think the VXLAN network might be the only one doing jumbo frames. And I hope that's big enough to see, but that's kind of how our physical network infrastructure works. Each data center has a core. Actually, technically, it's a pair of cores in Failover. They interface to the top of rack routers, and then we have the VLANs coming off of them. Now, this slide shows a really basic NSX routing setup. You connect an edge gateway, which would be the middle layer, to the top of rack router. We have it set up with OSPF, so it participates in dynamic routing. It drops down to a transit network, which is basically a virtual network segment, which then connects to the distributed routers on the host. For whatever reason, they gave me a good reason that you cannot connect the distributed routers directly to the network. And it's basically because it's distributed. It's going to say, yeah, I have a route to this, but it can't really, it operates as one virtual router. And then the VMs connect off of the distributed router. That's like just a bare bones setup. Now, at this point, there's obviously single points of failure because it's only connected to one side. And the edge gateways that are connected to the physical routers, they cannot migrate to the insides because it's separate IPs. I did try and see if I could set them up where they could have multiple interfaces. Yeah, it didn't work. Bad idea. Basically, they were advertising routes to a place they couldn't get to, which, So, in order to deal with the single point of failure in physical networks, created a second router on the opposite side. We costed it higher so that it's basically go back up. So traffic coming through the core, and I'll touch on this a little later. We did set it up so that VMs have a preferred site, so that the traffic to them can be routed optimally. You didn't want traffic going from the schools way up at the top through one data center just to hop back over to the other data center because we had bandwidth concerns at the time. We wanted to make sure everything came in and went straight to where it needed without any unnecessary detours.
Where did you implement all this? When did you implement all this?
About a year ago is when we went. The other thing that's way too small to see, we did cost all of the physical connections really high with OSPF, just to make sure the virtual infrastructure would never become the cheapest path between the two sites. Because if that happens, the routers are routing things into the virtual infrastructure. The virtual infrastructure is basically sending them back out to the routers to go to the other site, which would then create definitely don't want that.
Are you open to sharing your slides on the cert?
Yeah, cool. Yeah, I will make sure they end up somewhere.
All right.
Maybe with a larger version of the picture. Okay, so the edge service gateways have a bandwidth limit of 10 gigabit. We weren't sure if that was going to be enough, so we went ahead and doubled it up so that we have two. Also, might give a little better redundancy in case something fails. It might be able to recover it much faster. And then, this is still an active passive configuration. Every networking wise, we don't want that. So we doubled it again. So basically, we have a routing setup that's preferred for one site, a routing setup that's preferred for the other site. No, I did not come up with this design. I found it up the internet and said, hey, that looks like what we need.
Where'd you find it? Do you remember?
No clue. Plenty of resources though. And now, the next thing we added is our management network is isolated at that point. We can't route to the management network with a physical router because if that site goes down, the router at that site will go with it. And you can only effectively have one default gateway on the network. So we made the default gateway a virtual machine. So we can get into the management stuff as long as that VM is up. We have spare ports on the physical switch, those the top rack routers. So if something happens to that, we can still plug into the management network. It's kind of an elegant way to deal with something pretty sticky otherwise. And then, just because, or eventually we will have a DR site. We're just going to, when we do that, we'll extend it out just a little bit more because our DR site will have machines that run there permanently.
So your two sites geographically, how far?
A couple of miles. Not enough for not enough to qualify as disaster. It is truly just high availability. However, we've had enough problems with data center availability, even big ones, that it's important.
So are you looking to run in production at your disaster recovery site?
Do what?
Run in production at your disaster
There
recovery
will
site?
be certain things that will run there permanently. When we do it, if we're still using ADFS, we will have an ADFS instance there. There will be Active Directory controllers there, just to provide authentication in case the other sites go down. The other thing I'm looking at is when we bring up a DR site, external DNS services would move there. Because if there's a disaster or we need to start making DNS changes, they need to be in a location that we can still get to, because we won't be able to rely on our backup server. Basically, we don't want to have to call up the ESP and say, hey, can you do this real quick? We had a disaster, because the type of disaster that's going to take out both of our data centers probably took out theirs too. So our primary is off on the other end of the internet. Then in case of disaster, it's still there.
Do you have an idea where that DR site's going to be?
Not at this time. That's a problem for my boss. Actually, I think what we're going to try and do is work out an agreement with somebody else further inland into the country and just do a swap. I think we can do it. And even then, like co-location services are cheap. Then you don't have the cost of, or the variable cost of running a cloud service. Server groups, and I kind of started to mention this. It's not a VMware thing. It's not what I'd call a standard practice. It's something we came up with to break things apart into small enough groups so that we can manage them a little more effectively. Basically, it's like all of our Synergy web servers. It's a group. We consider it our smallest point of, or smallest group balancing. So if we want to pick up a server group, we want all of the group to be at a single site, so that if they're talking to each other, they're not talking across the internet. Yeah, we group things together kind of based on function. Depends on what, we have a few groups of one-offs. In VMware, we created a VRS rule that basically says, this is your preferred site, stay here if you can. If not, it can, basically it'll always prefer a specific site, if that site's online. Each server group gets its own IP network, and it's a small network. We're averaging either 8 or 16 IP address networks. So our networking team, since we moved private, they gave us a Class B to work on. And at this point, we've chewed up three or four Class Cs with small, literally bitty networks. Those networks are attached to the distributed router.
You'll have to hit source and yeah, because it defaults to their thing if it loses signal. It's on the top. Oh, no, never mind.
Oh, yeah. And each of those small networks is attached to one of the distributed routers based on what site is its preferred site. This causes the network routing to be optimal for grouping, regardless of what site it's at, as long as it's running on its preferred site.
Just to clarify too, so you're using private IP ranges for that. Are you exposing the private IP to that, or are you performing that at some phase between them?
Our internal clients are using the private IPs. Okay. And
if you have a need externally, then you handle that. Okay.
That was actually a really big part of the project too.
Okay.
But yeah, that's a couple slides away.
Okay.
Basically, we can set this up optimal routing so that if it comes in from a school, it will go tab and not go through the opposite data center to get there. It doesn't affect high availability at all. It just kind of helps us keep things moving. We can tweak the balance of the load between the sites. We decided to not have a single or a small number of really large load balancers. We broke it down into the Synergy web servers. Boom, that's a load balancer. It's the parent view servers. Boom, different load balancer. We want to make sure if we're doing big changes for one service, it does not impact another. And having them completely separate takes care of it. The really small virtual appliances, a couple of CPUs and something, 1 gig of RAM. So really lightweight. We do use them for synergy, things like load balancers, they work great. We use it for DNS, Active Directory for the systems that don't actually support Active Directory. And we generally put those load balancers in attached to the same networks so that everything moves together. There are 2 basic configs for the load balancer. We've got one arm and inline. The one arm, basically you can attach it anywhere. Clients are pointed to it. It regenerates the connection back to the end servers. That's probably more common. The only problem with that is the original IP address of the client does not get exposed to the server, which, if you're trying to log things, is bad. You can inject it into like HTTP headers, but if your application doesn't support it, then it doesn't help. But one arm config only affects traffic that's going through the load balancer. And so basically, we have a VM, load balancers, basically just the same. We've got inline load balancers, and the difference here is the load balancer becomes the router for the network, serving machines and balancing. Because of this, it can do NAT. So basically, it'll do a destination NAT, and it preserves the IP address all the way through to the server. Disadvantage, all the traffic to that server goes to that load balancer. So, if it does HTTP and file sharing will still go through that machine. And that's kind of how it looks. Basically, instead of connecting it to the load or to the distributed router, the load balancer becomes the router and connects it directly to the transit. Public IP addresses. That was one of our issues. Big challenge here is in order to do NAV, the spot where you're doing NAV has to be the only path between the source and the destination. Because if you have 2 routes and one of the packets goes out the other route, it will get 8. And with 2 data centers, 2 connections to the internet, and full redundancy everywhere, the only place we can actually do it right up against where the virtual machine is. I guess, okay, the other option is synchronizing firewalls, but that is the bandwidth load on that. Our networking team just didn't do it, which is probably the right decision. Let's see. The VMware distributed routers don't support NAV. They literally just do routing. So we cheated. We didn't do NAV. We did aliases. So our servers that are exposed to the internet have 2 IP addresses, the internal one and the external one, which is a secondary address. We then publish that address, or set up a static route in the router that feeds that network, and it distributes that information to the rest of the network. So basically, it's a single IP route, and it gets it back.
So if the VMware, if the virtual machine needs to be migrated or anything like that, does that ever cause you any conflict with that?
No, because it's the router that the VM is connected to is the same. So it's not been an issue so far. Where it does, it can create issues because by default Windows will not send any connections out via that IP. It'll always use the primary IP of the network interface. It's not been an issue for us because most of our connections are incoming. We did have an issue with our external DNS servers, and actually Microsoft already had a way to fix it. So I think there was a registry key saying, yeah, always use this IP. If we really needed NAV, we could set up a small virtual router that would deal with it. But at this point, we're just using it. Now those public IP routes don't go all the way to the internet. Our internet provider basically says, this block of addresses goes there. So it actually worked out pretty good. Okay, so I'm running really late. I'll just keep going. Don't throw me out. How's that sound? The security portion of it. VMware has a distributed firewall, which is host integrated. It literally lives with the VM. It follows the VM. Since it's distributed, the workload associated with it will automatically be distributed across the cluster. It is truly in that first level. Your vendors can't unless you give them access to the virtual machine, which you do. Kind of. I think the version we're using has, I believe, some. I believe that they just redid the licensing model, renamed the product, added a bunch of new features. I believe that the Edge Service Gateways also have firewall capability. As long as they're not doing CMP routing, because you can't really do stateful packets effectively on a system that has parallel connections. Otherwise, packet A goes to one firewall, packet B goes to the other one, which is intentional. VMware has grouping objects, security tags, basically assigned to VMs. Basically, literally, just flag, save, whatever you need. They have They also have IP sets for things like not virtual machines or managed specific. Security groups are basically what you can apply to things. The security group basically just rolls up the security tags, IP sets, VMs folders. Pretty much, you can make a security group out of just about anything in the VM. So you can say everything in this data set or whatnot. We use security groups to assign firewall rules and load balancer destinations. So, an example, we have a security tag named HTTPS from public. It's associated with a firewall rule that basically says packets from anywhere will go or create any server that is tagged with that. So we're not micromanaging firewall rules, at least not for stuff that's highly used. So we have HTTPS from public, HTTPS from user networks, which we define as the user networks that users should actually be on. So not the home network, not the guest network, and such. Another slightly more advanced example, we also have a security tag named load balancer enabled. By itself, doesn't do anything. But for like Synergy, we have 3 Synergy web servers. They're tagged with Synergy web server, which is associated with the firewall rules that Synergy needs. We created a security group that says if something is in load balancer enabled and the web servers. Set that as the destination of the node. So we don't have to, if we want to pull a security web server or create a new one, all we have to do is we don't have to go in and tweak program. It makes it convenient and basically less idiot-proof. Because
Maybe it applies to automation too.
actually, yeah, that NSX does have full API, so I mean, a really nice PowerShell setup for it. Just about anything. And yes, I found one thing that it could do with PowerShell. The PowerShell modules gave me the hooks to build it myself. And that was installing certificates. Because we moved to Let's Encrypt, and we needed a way to push certificates into those websites. We have lots of IT sets for user networks, phone networks, guest networks. We use security groups to roll them out. And those are site specific because nothing sucks worse than to have a list of 100 networks in a group. It's like, okay, which one's which? So we actually set up site specific. So school X, Y, and Z user networks, there's one big range. We use security groups to roll them up into like all user networks, all phone networks, all guest networks. And we also use security tags to override because we have remote desktop servers. We consider that as a user network because we standard firewall rules that we did. Standard firewall rule that all VMs get is everything is blocked.
So on that front, in an earlier slide, you said you don't rely on the host-based firewall. So how do you?
We
How does that work?
rely on guest firewalls, the ones in the guest VM.
Oh, okay.
Because people tamper with them.
Yeah.
The VMware
So
firewalls,
yeah.
much more limited scope.
Okay.
A couple of people can do those. We have some security tags like standard Windows firewall rules. It allows all outgoing connections so that, at least for phase one, phase two may be a little bit different. Then incoming ICMP that so that people can communicate and such. We also, like for standard Windows rules, we have a security group for sysadmin networks. So we allow RDB and SMB from sysadmin networks only. So kids in the schools can't even get an RDB connection to the server. And since everything is blocked by default, unless something is specifically allowed, it's denied. Of course, we have system-specific rules, lots of those. I actually thought it was going to be a huge task to develop those, but I figured I'd meet with the trick. Call up the vendor right before they do the install and said, yeah, please send us over the firewall rules so that we can get them in place. Otherwise, everything is blocked by default, and it's going to cause you grief. So if they're doing the install, it saves them a lot of time to get the information to us in advance. Otherwise, we have to basically guess and check and figure out what's up there. And the firewalls do have logging. We don't log firewall stuff unless specifically looking for it. Because otherwise, when I said we block everything, I mean we block net BIOS traffic. Even from machine A, machine B right next to it on the same network, it's still, there's just no reason for it. But yet Windows still leaves it all day long, so we definitely look for a lot of everything. Okay, so that's all I have. If you have questions, that's my email address.
How long did it take to plan or
We were beating around with testing and stuff. I think we worked on it for a year before we did 3 or 4 installs. But we did that when we did our database cluster. We did 3 or 4 installs. We cleaned everything out. The first one was just to play with it. The second one fixes the issues and realize that we shouldn't have done it in the first one. The third one is to document.
And you guys did that all yourselves. You didn't have professional services come in and help at all, really, did you?
The recommendation was 3 weeks of professional services. My experience with any vendor doing it, it's not vendor specific. They're there just to get it done, get it out the door. They're going to do it the way they do it for everybody else.
Mm-hmm.
They don't need to understand our environment. Everything that we've ever had done by a vendor, almost always.
I don't have many customers who are capable of doing what you did.
I read the book
It's impressive. Yeah, well, not a lot of people read the book.
a couple of times. And
So, yeah.
the challenge with NSX, there's a lot of fine points and interactions
There's a lot of nuances and
that you
little.
just don't realize.
Yeah.
Kind of like, I don't know if you were here, but like the network controllers, not stretch friendly.
Yeah. Yeah, well, and it used to be where they would recommend having you could have 3 or 5 controllers, and you'd have 3 in one site and 2 in another or something, and
Yeah, but if you
they
don't
kind of
have
changed it.
50%, then it's
So
still not.
yeah.